some prior skills, some just skills we should know from previous courses. The biggest one is rounding, because remember, if you round incorrectly with your numerical response, then even if the question is technically correct, because it is machine graded, it will be marked incorrect. All right, so rounding a number to the nearest whole number, we want to round to the number before our decimal place. So then we look to the one after it and we see, is this number big enough to bump us up, or is it going to keep us the same? Well, 1 is less than 5, so it's going to keep us the same. So we're just going to write 12. Not 12.0, because we want the whole number, so it's just 12. All right, again, round to the nearest whole number. So I look here and I see, is that enough to bump us up or keep us the same? That one's going to bump us up. Round to the nearest whole number, look here. Yep, that's enough to bump us up. We're going to go to 16. Rounding to the 4, look 3. 3 is not enough to bump us up. We're going to stay 24. All right, nearest tenth. Nearest tenth means 1 decimal place. So that means now I'm rounding to here. Again, we look to the number right beside it, just the number right beside it. 2 is not enough to bump us up, so we're going to stay at 12.1. Okay, this is where I want to round to. Look to the number beside it. 9 is enough to bump us up, so we're going to be 0.9. Here, 9 is enough to bump us up, so that's going to bump us up to 10, which means it's going to actually bump us up to 16. But because we want the nearest tenth, now we have to do 16.0 to make sure that we're keeping that nearest tenth. Nearest tenth, that's the 3. Look beside it. That's enough to bump us up. 24.4. Nearest hundredth, that means 2 decimal places. So now I'm rounding here to the nearest hundredth, looking beside, not enough to bump us up, so it's going to stay 12 and 12 hundredths. Looking here, beside us is a 2, not enough to bump us up, it's going to stay 0.89. Rounding to the nearest hundredth, looking beside, okay, that's enough, so that's going to bump us up to 10. Which means that's going to go to 10, which means this is going to go to 6. So the only time we progressively round is when we're rounding from a 9 to a 10. Then we kind of have to change decimal places before. Anything else, we only change the number that we want to round to. So this is going to be 16.00. Again, we want the 2 decimal places to make sure that we're to the nearest hundredth. Okay, so I'm looking here at the 8. 9 is enough to bump us, so that's going to be 24.39. All right, at nearest thousandth, this is now 3 decimal places. Okay, so we look here, look to the one beside us, see if it's enough to bump us up. It is not. So we're going to stay 12 and 123 thousandths. Look in here. Yep, 8 is enough to bump us up, so 893. Looking here, 9 is enough to bump us up, but it's going to bump us to 10, to 10, to 10, so that means that's going to become a 6. So 16.123, because remember we need 3 decimal places. Okay, looking at the 9, 1 is not enough to bump us up, so 24.389. So rounding is a very easy skill, and it is also an easy way to lose marks if you do it incorrectly. So make sure you're reading the questions carefully to know which one we're rounding to, and always look just to the right of that. Is it enough to bump us up, or is it going to keep us the same? Okay, other prior skills that we need that are going to help us mostly in our rational expressions unit is solving quadratics. Again, there's 3 different ways to do it. You just have to know one of these. This way, using our formula, and graphing works with all equations. Factoring only works with equations that are factorable. Okay. So when we're factoring, we need to look here and we need to look here. And we're going to need 2 numbers that add to be -1. And those same 2 numbers need to multiply to equal -12. So this is going to give us -4 plus 3 is -1, and -4 times 3 is -12. That means this is going to be factor 2, x minus 4 because of the -4, and x plus 3 because of the +3. And if we're going to solve this, we need to equal it to 0. So we just take each factor and set it equal to 0. So x equals 4, because we just add 4 to both sides. This one, x plus 3 equals 0, minus 3 from both sides. We get that x equals -3. All right. Again, this works and is really nice, but it only works for equations that are factorable. The equation is not factorable, then you have to either use the formula or graphing. So remember, our quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And we have a is the number in front of our x squared, b is the number in front of our x, and c is our number that doesn't have an x. So we just have to sub those values into our quadratic formula. So it's going to be -b, well, b is -1, plus or minus the square root of b squared, so -1 squared, minus 4, a is just 1, and c is -12. And this is all over 2a. So we can just put all of that into our calculator, or we can simplify it a little bit. So if I want to simplify it a little bit, negative into negative, that's going to be a positive. -1 squared, that's just 1. -4, -12, that's going to be plus 48 all over 2. Again, I'm going to just simplify this down a little bit more. 1 plus or minus, well, 1 plus 48, that's 49. And the square root of 49 is 7. So our x values are going to be x equals 1 plus 7 divided by 2, which is going to be 8 divided by 2 is 4. The other one is x equals 1 minus 7 divided by 2. Remember, we do have that fraction button on our calculator. So 1 minus 7 divided by 2, -3. Using that fraction button, you can just enter it in right from this original get-go here, but you have to be sure to enter it exactly as I have it written. So that's the trick part, and that's why sometimes simplifying it on paper first helps. But if I do this, let's say I want to do the plus 1 first. So I'm going to go -1 plus the square root always put this in brackets or your calculator is going to spit out the wrong answer because it's going to do negative 1 squared instead of negative 1 squared. Okay, minus 4 times 1 times negative 12 all over 2 times 1. So you can see we still get that 4 answer. And if you do it this way, we can just scroll up, enter that. It's going to copy it back down. Then I can go over here and change this plus sign to a minus sign. And that's going to give us the negative 3 answer. The third and final way of doing this is by graphing and using our calculator. So this is specifically with the graphing calculator. So we're going to go into y equals, and in y1 equals, we're going to put in x squared minus x minus 12. Squared minus x minus 12. And we are going to graph that. So now we need to be able to see our x-intercepts because that is what we're looking for. We're looking for when y is 0, so that's our x-intercepts. So for your windows, you need to see x-intercepts. Remember, if you need to change those, you just go into Window. And if I want to move this way, you're going to change your X max. So if I look at our window, I would change my X max. If I need to move it this way, I'm going to change my X min. If I need to move my graph and see more this way, I'm going to change my Y max. And if I need to change my window and look down this way, I'm going to change my Y min. Once you can see those x-intercepts, you're going to go to your graph and you're going to go second trace. We're looking for the 0. So if I go down to the 0, so it's going to ask you a left bound and a right bound. So you have to find one x-intercept at a time. So it's always going to ask for a left bound and a right bound. So in this particular graph, because of the way our parabola opens, so we're opening like this. If I'm looking for this x-intercept over here, then we're going to have left bound is going to be over here, and the right bound is going to be down below. I'm going to scroll over till I'm on my left bound, hit enter. You can see now it's asking for right bound, so we're going to scroll over, hit enter. Make sure my my x-intercept, is between those two arrows. Once it is, hit enter, and we get that x equals negative 3. If I want to find the other one over here, well, that gives me a left here, and that gives me a right here. So again, we're going to go second trace, we're going to find the 0, scroll over, and I can be anywhere to the left here. So I could be here, I could be here, I could be up here, as long as my cursor is to the left of that x-intercept. So I just have to go to the right, so there is fine. I can hit enter, make sure my x-intercept is between those two arrows. It is. Hit enter, and we get our other guy that says that x equals 4. So formula graphing works for any quadratic. Factoring only works for factorable quadratics. If my graph was the other way around, and we open down, then we have left bound here, right bound here, left bound here, right bound here, when you're looking for the specific ones. So if I'm looking for this one, it's left bound, right bound. If I'm looking for this one, it's left bound, right bound. All right, the other prior skill that we need, again, mostly for when we're solving rational expressions and for our exponential unit, is solving linear functions. So sometimes they're this long and convoluted, sometimes not so much, but it doesn't matter what we throw at you, the steps are the same. So step 1 is you're going to distribute to get rid of brackets. So it's also known as fireworks, so distribute to eliminate brackets. So that means I'm going to take this 2 and I'm going to distribute it into both of those terms. Remember, there's a -1 here, and we're going to distribute that to eliminate the set of brackets over here. So that's going to leave me with 3x plus, now it's going to be 2x plus 2 equals 4x, and it's going to be minus 7x minus 14. So we can simplify each side. So we're going to go group like terms each side. So these two can get grouped together. These two can get grouped together. So we're going to have 5x plus 2. It's going to equal -3x minus 14. All right. If it's a question like this one where we have x's on both sides, we need to move x's to one side and numbers to the other. Meaning, and just because I don't like dealing with negatives, I'm going to move this -3x over here to join by adding 3x to both sides. So -3x plus 3x cancels that out, which means because I moved x's over to the left side, I'm going to move numbers over to the right side. So I'm going to subtract 2 from both sides. Again, that's going to eliminate on this side. So that's going to give us 5x plus 3x's is going to give us 8x, which is going to equal -14 minus 2. That's going to be -16. And finally, we can solve for x. I only have one x now, it's all on one side. So to solve for x here, I just have to divide both sides by 8. So x equals -2. So remember, you can always verify any algebra question. And you just want to make sure that your left-hand side equals your right-hand side when you sub in your answer that you think is right. So our left-hand side, we have 3x plus 2x plus 1. Right side, we have 4x minus 7x minus 14. Okay, so I sub in -2. It's 2, -2 plus 1. Well, that's going to be -6 plus 2 times -1. -6 minus 2. So that's -8 on the left side here. Again, you could just put this into your calculator. So 3 times -2 plus 2, -2 plus 1. But sometimes they'll ask you this in a diploma question. Well, they'll show you steps like this, and they'll try to ask you what is the person trying to prove. So because what we subbed in is 2, what we're trying to prove, or sorry, what we subbed in is -2, what we're trying to prove is that -2 is a solution. Okay, so on this side, we're going to sub in again -2. 7 times by -2 minus 14. 4 times -2, that's going to be -8, minus 7 times -2, that's going to be -14 minus 14. Well, -14 minus 14 is just -28, which is something's wrong, mother truckers. All right, so let's go ahead. 4 times by -2. Some typo here, this should be plus from our original function. Minus 7 times by -2 plus 14. So that's going to be -8 minus -14 plus 14. Well, that's just 0, so -8 minus 0, which is -8. So seeing as left-hand side equals right-hand side, we know that -2 is a solution. Remember, always double check your work when you're dealing with algebra.